Albert Einstein used relativity to explain how the speed of light is constant, regardless of the source of light or the perspective of the observer. Scientists have proven over and over that both length and time shorten at high speeds. Therefore, we always observe light to travel at the same speed because the components of speed, that is, distance and time, shorten at high speeds. Light speed is constant for what we call an inertial frame of reference, in which velocity does not change. However, if motion is disrupted by an external force, then velocity is changed. In other words, acceleration occurs. Now, light is no exception to the laws of physics, and Einstein knew this. He knew that light was affected by the force of gravity, that is, light bends towards an object with mass. As light changes its direction, it changes its velocity, or simply put, light accelerates. Therefore, it was necessary to distinguish between what we call special relativity and general relativity. Special relativity accounts for the constant speed of light in an inertial frame of reference, that is, no gravity. In other words, light speed is constant as long as it is moving in a straight line through space with no surrounding mass. Now, general relativity is needed to account for the effect of gravity on light. We all know gravity works. In fact, gravity has become commonplace in our daily conversations, but this has not always been the case. Newton changed our understanding of the universe when he postulated gravity to be the same force responsible for holding planets in orbit and pulling apples to the ground. His ideas of motion are so readily accepted that they are referred to as scientific law. For years, it was enough to simply know that gravity exists and its effects are readily apparent. However, nobody really knew what gravity was or how it worked. Newton thought gravity to be an instantaneous force. In other words, the effect of gravity is noticed as soon as a mass appears, and its effect is lost the instant the mass is removed. For example, if the sun were instantly removed from our solar system, the Earth would instantly spin out of orbit and travel through space in a straight line. This was acceptable until Einstein postulated that nothing can travel faster than light, including gravity. If gravity cannot travel faster than light, then the effect of gravity would be dependent upon time. It was no longer sufficient to simply appreciate the existence of gravity. This sparked science to reopen the case of gravity in search of its very nature. Einstein thought space and time as a single entity, and he referred to it as space-time. As space is defined by three dimensions, that is, length, width, and depth, time became the fourth dimension in space-time. He imagined a continuous space-time fabric to hold objects together, including planets in our solar system and galaxies in our universe. It is helpful to think of space-time as being like a trampoline. Planets would be like people sitting on the trampoline. Objects would create a dimple in space-time, just like they would on a trampoline. If a smaller object is rolled close to the larger object on the trampoline, the smaller object will bend its direction towards the larger object. Perhaps this is how gravity works. Smaller objects would change their state of motion towards and around the larger objects in space-time, much like on a trampoline. Likewise, if an object is removed from space-time, so is its effect on space-time. A wave would be spread away from the object once removed. Therefore, it would take time for this effect to be noticed. In other words, gravity is not instantaneous, but rather gravity is dependent upon the effect of mass on space-time. As I said before, light is no exception to the laws of physics. Just as a small marble would roll towards a person sitting on a trampoline, light would bend towards a large mass in space-time. In other words, the speed of light is affected by gravity. Science has demonstrated the speed of light to decrease within a gravitational field. General relativity uses space-time to account for the effect of gravity on the speed of light. In summary, the speed of light is constant in an inertial frame of reference in which velocity is constant. Special relativity accounts for the constant speed of light in this inertial frame of reference, that is, no gravity. Gravity is an attractive force between two objects that have mass. As light approaches mass, it is affected by its gravitational pull. Light bends and changes its direction within the gravitational field. This change in direction is a change in velocity. Therefore, light accelerates within the gravitational field. Specifically, light speed decreases in a gravitational field. General relativity accounts for the effect of gravity on light.